situation with the suicidal thing, you know. And when I was a kid, people always told me what I couldn't do, you know. And to this day, it pisses me off because everybody always told me what I couldn't do. Nobody told me, like, give me guidance on what I could do. And half the stuff I've done, I never would have been able to do it. And I didn't think I could until someone said, you can't. And I said, wait, I can't. And I said, well, maybe I can't, but I sure as hell gonna try, you know. And that's the whole reason why we're here right now, you know. We started off on our kitchen. The first time when we were playing, people were, what are you gonna do that? No one's gonna like what you're doing. That's like, okay, well, if we're wasting our time, let us waste it. You worry about your time. Sometimes you gotta fight with your fist, sometimes you gotta fight with your mind. And that's the whole reason why we're here right now, you know.
Hello and welcome once again. La, 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 la. It's me, Miss D, your host for Filler Metal Selection. Shield metal arc welding electrodes. Da, 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 da. All right, so stick electrodes or simply electrodes or sticks or rods. An SMAW electrode has two parts, the core wire and the flux coating. So the core wire, this is where the size of the electrode is taken. So an 1/8" electrode has an 1/8" core wire, okay? And then we have the flux coating that covers it, okay? So what does an SMAW electrode actually do? Well, first, it carries the current. Anytime you see the word electrode when it's used in welding, we're talking about something that's carrying the welding current. In most cases, like in SMAW, the electrode melts and it's used as a filler metal and makes the finished weld. The other part of the electrode, the flux, it provides alloying elements. Alloying elements, remember, means to add elements to make the weld better. So arc stabilizers are usually included in the flux. Also, the flux can help bring impurities into the slag and create a slag to protect the weld bead while allowing it for it to cool down slowly. Flux, it also provides a shielding gas during welding to protect the weld from the atmosphere. So these rods are actually doing a lot of work for you, which is super cool once you guys understand the science. Just checking. All right, so we talked a little bit about silicon and manganese earlier. So here we have how they work as scavengers taking out the contaminant. So here it is. Here we are. Let me help you take it out and help you put it into the slag. So selecting an electrode, it can be a really big task. As an entry-level welder or even a seasoned welder at larger shops, you're going to rarely have to choose the right electrode, but there will be times in your career as a welder or as an independent contractor, you need to make that choice and you need to understand how to do it. So there are a ton of variables and conditions that you might need to think about before you select an electrode. So you can see that some of the most common ones like current and power source, regardless of the type of welding, current and power source are important. You have to have a machine that uses the type of current and power source that the electrode needs to work properly. The type of base metal and thickness also play a part in what to select, just as much as joint design, surface condition, and service use, and so on. So let's kind of go over some basic rules that kind of helps us pick what we're looking for. All right, so there are, here, I have a couple of rules that I worked with during my welding career, and I hope maybe this can help you too. All right, so rule number 1, match your filler metal with your base metal. Okay, this means if I have a steel base metal, I want to use a steel filler metal. If I have aluminum base metal, I want to use a aluminum filler metal. Pretty good, right? Okay. Rule number 2, the filler metal should be as strong or stronger than the base metal. Well, what does that mean? Well, it means that you need to match the tensile strength of the base metal with your filler metal, okay? Your weld should outlast your base metal. We want to show people that we have a super weld and their base metal was garbage, All right, rule number 3. 90% of your decisions are going to be based on thickness of material. Your settings are based on how thick the material is. The base metal might also dictate the edge preparation that you may need to be used. And you may have a choice of filler metals. One could be shallow penetrating and the other deeper penetrating with some of the same characteristics. So if your metal is a thinner metal, you may not want a deep penetrating rod. So that helps also selecting the correct rod. Okay, so some codes and standards require low hydrogen electrodes to be kept in a heated oven at a particular temperature to avoid getting moisture or hydrogen into the flux. So the oven on the left, this one right here, is a little small electric powered oven. They also have like these little thermos kind and kind of can be plugged into a car adapter to keep warm. Okay, so the first thing is we also need to understand the difference between classification and specification. Simply put, I'm going to try to make this as simple as possible for you to understand. An AWS, American Welding Society, specification is the container. All right, so my picture here shows me a barrel of monkeys. Okay, here's my barrel of monkeys. Okay, so the container reads AWS A5.1, which is the specification for SMAW mild steel electrodes. Or it can just say barrel of monkeys, right? I'm telling you what's in the barrel. So the monkeys in the container are the classifications. Each monkey has his own name, like Luke or Skywalker or Leia or whoever. We can now name it. So a classification is a name of a rod, like E6010 or E7018. So we can see that that barrel of monkeys and the names of monkeys are just like my specifications. We can also notice that it's a specification because it has a speck in it. It has a dot in it. It shows me a specification. We're specifying it's this under this roof, but we need to be more particular with a classification. All right, so we're going to talk about AWS filler metal classifications. So we're talking about particular rods. So this goes for many different processes. So here we go. The prefix letter, or the letter that is first, okay? This tells us the user, the form or type of filler metal that's going to be used, or how it comes in. It comes in a rod, or is it just an electrode? Remember that not all of this is seen on a daily basis, so unless you use some of the particular processes, you might not see it, okay? So let's go. So here it is. Here's our prefix letters, means the first letter before all of the numbers. E, this indicates that this filler metal is an electrode. So we know that electrode carries electricities. You will see this in GMAW, FCAW, SAW, and ESW. All right, R, this indicates a rod. Rods are usually cut to length or can be a wire roll. ER, this indicates that it can be as an electrode and a rod, or either or, okay? So the same alloys are used to produce the electrodes and the rods. It just might be supplied on a wire spool for GMAW or as a rod for GTAW. All right, EC. You probably won't see this very often, but this indicates it's a composite. And this is usually used for SAW, or submerged arc welding, and no, this is not underwater welding. B, this indicates this is a brazing filler metal. Brazing fillers can also come as powders, sheets, washers, ring, just about anything, okay? RB, this tells us the filler can carry current or be used as a rod or both. So this is usually used for braze welding or oxy-fuel brazing. RG, this type of rod is usually used with oxy-fuel welding. IN, this is a consumable insert, meaning that it is used as a backing, like in a root pass, and it actually gets made into the weld without being removed, like some types of backing strips. EW. EW says this is not consumable. This is a non-consumable electrode, means that it's not going to be used during the welding process and get made into it. The E tells us it's carrying current. The W is the chemical symbol for tungsten. And this is going to be used for GTAW. Okay, here we go. Couple of others. Keep them going, right? F. This tells that the flux is used for submerged arc welding. So remember, this is an underwater welding, but a process kind of like FCAW with more fluxing agents. So there are alloys in the flux that dissolve into the weld metal. So the filler metal and the flux actually have to be specified separately. The filler metal is identified and then the flux is identified. So there are some things called suffix identifiers. Okay? Suffix means at the end. So this can indicate how much hydrogen is a particular filler metal. All right. Whew. The specification for carbon-covered electrodes for SMAW is AWS A5.1. The specification for low alloy steel in SMAW electrodes are AWS A5.1. Okay, you can remember that because there's a spec in it, or a point, and remember this specification, this is the barrel, this holds everything. Alright, so each specification of electrodes have differences in how the information is given, and it's kind of like a little code, but once you figure out the code, it makes it so much easier to understand. It's kind of like a shorthand. Alright, so we went over prefixes. The prefix here for this is E. We know that E is for, hold on, let me hear it, electrode. Okay, heard you guys. Alright, so the next 2 or 3 numbers, they refer to the tensile strength in 1,000 pounds per square inch. So the 60 here would be 60,000 pounds per square inch. And we can go all the way to 110,000 pounds. All right, the third digit, number 3 right here. The third digit, this is the position the rod can be welded in. If we see a 1 here, this means all positions, flat, horizontal, vertical up, and overhead. Now, if this number is a 2, 2 is for flat and horizontal fillet only. 3, it's not used anymore. It was used a long time ago and has since been removed. All right, last one is 4. 4 is for flat, horizontal, vertical down, and overhead. Do not get 4 mixed up with 1 because with 4, it does not do vertical up. All right, the last digit. The last digit tells us the polarity or the welding current and the composition of the flux. So we can see here the last digit and the current required to run the electrode, as well as what type of coating or flux is it. So this is kind of cool. So we know that type and coating of current is on the end, this last one, this last digit here. If it's 0, it is high cellulose sodium, and it must be run on DC+. All right, how about for a 7018? 8, right? So I'm going to look at my 8. Low hydrogen, potassium, iron powder. It can be run in AC, DC+, or DC-. All right, so it tells us all of this information without me having to go look, oh, what is it and how do I run it?
Stay tuned for another part.
Weld the world. Weld the world.